Where's my... It's actually a video on pole topping, and that's going to be something that you're going to do going to work for a utility, because that is something that will have to be done when you're changing out a pole that is in line. And of course, it's going to be in a little tight spot up there, so you're going to have to take a chainsaw and do some pole topping. So let me share my screen with you guys. And please let me know if you can see that. All right, guys, y'all see that?
Yes, sir.
Yeah, we see it.
All right. All right, here we go.
Here we go.
It was a cold, rainy day, one that had followed several other days just like it. On Tuesday, September 16th, 1997, the Weather Service reported a full inch of rain had fallen during a 24-hour period. The accident occurred at approximately 3 o'clock in the afternoon. Jerry Cade and his crewmates began topping the 5th pole, their last job of the day. Jerry and a crewmate were working up in the bucket truck. The top of the pole was tied off with a line and secured to a tree nearby. A third ground crew member put tension on the line to pull the top of the pole away from the crew in the bucket truck toward the tree. Jerry was operating the chainsaw and he made the cut. There is some uncertainty about how the accident happened. The pole falling wrong may have been due to the weight of the insulators or the cut used, causing the pole to twist toward the boom.
The 20-foot piece of pole fell toward the bucket, breaking the boom and throwing Jerry, who was not tied in, out of the bucket. He fell 20 feet to the deck of the truck below. His partner managed to stay in the bucket without getting hurt, but Jerry did not survive the fall. Due to massive head injuries, Jerry was gone before medical personnel arrived. Unfortunately, there are no official safety codes when it comes to pole topping. After looking into the cause of Jerry's death, Aztec Electric and the Department of Labor and Industries felt it was important to make this video to demonstrate safe pole topping methods and show it to everyone from the experienced veteran to the first day employee on the job. I'd like to run through the safety checklist every employee on a pole topping job site should know. Before a crew ever starts a pole topping job, it's important to complete the following checklist. The purpose of forming an initial safety plan is to review each job site for ground and weather conditions, locate any potential hazards, locate all electrical lines and sources in the immediate area, establish safe truck positioning, inform all employees of job site conditions, the types of pole cuts and how they are used, and answer any questions employees have regarding safety policies and procedures. This information is gathered and discussed at the first tailgate safety meeting. It's important to always review and double-check the clearance requirements anytime a crew is working on or near energized lines. Contact the owner or serving utility of the line to obtain clearance necessary to perform the job. Document the time and person giving your crew clearance after it has been obtained, and make sure all grounds and shorts are applied. Every job is different. The foreman and crew must conduct a meeting to review the work to be done at the start of the day's work and anytime working conditions change during the day. The tailgate team meeting should include review of the job site-specific safety manual, safe working conditions as outlined in the Washington Administrative Code, determine what safety equipment will be used, decide which lines will be guarded with what types of barriers, discuss type of cut to be used, a wedge cut is the safest, decide on the safest procedures for removal of the pole tops, and discuss job site emergency procedures. Just as important as job pre-planning is having the right type of equipment on a pole topping site and knowing how to use it. General personal protection equipment must be worn at all times. The following is designed for your own personal protection as well as the protection of your fellow workers. Hard hats to protect you from overhead hazards. Safety glasses to protect your eyes from flying debris. Gloves to protect your hands from cuts and other hazards. Earplugs or muffs to protect your ears from loud sound levels. Full body harness, designed to distribute the force of a fall over your full body. Lanyard attaches a full body harness to an anchorage point in case of a fall. Flexible ballistic nylon pads or shafts to protect your legs when necessary. Lineman's rubber gloves, test certified with keepers. Used as personal protection barriers against electrical shock up to 5,000 volts. Rubber blankets, test certified, heavy rubber blankets to protect you against accidental contact and electrical shock when working on or near an electrical line. Spiral line sleeves, fiberglass cylinder-shaped barriers placed over and around energized or potentially energized lines. Grounding equipment, backup conducting connection equipment used in place of the earth. Other types of general equipment used on a pole topping job are aerial man lift or bucket truck, designed to elevate you to the work area on a pole. Line truck or digger derrick, used to secure the pole and remove the piece when the pole is cut. Hand line, a rope and pulley assembly used to raise and lower material and equipment. Rope slings, heavy braided rope or line used for rigging and securing the equipment to the pole for removal. Chainsaw, after the pole topping method has been determined, used to cut off the top of the pole in one piece or in several chunks. There are two recognized methods of removing the top of the pole. The first is called chunking. That's when the top of the pole is removed in several sections, such as these. For safety reasons, chunking is a preferred method. This allows the lineman easier control of the smaller pieces. This may take longer, but it's well worth the extra effort. After the bucket truck is positioned safely and the outriggers are on level, stable ground, all hardware and attachments are removed and lowered down on the hand line or with the boom and the line of the truck to reduce the weight on the pole. A piece or chunk is cut off the pole in a small enough section that an employee can remove it and lower it down with the hand line. This process continues until the pole is cut down to the desired height. An alternate method to chunking is the single section method. This refers to the removing of the top of the pole in one large piece. The bucket and line truck are stabilized at safe distances from each other with the pole easily accessible from either truck. The boom of the line truck is placed near the top of the pole where the single section will be removed. The two employees in the bucket take a sling up and attach it near the top of the pole utilizing a choker attachment. The sling is attached to the winch on the boom of the line truck. The ground operator takes up the slack on the winch line in order to place a small amount of tension on the line away from the employees in the bucket. The employees in the bucket truck then make one safe and proper cut. The ground operator then utilizes the line truck to move the single section of the pole away from the employees in the bucket and lowers the single section of the pole to the ground. After the top of the pole is removed, the crew spends the time to clean up the area of all the debris. The acting utility and owner are notified immediately that we are clear of the lines and leaving the project. This video is dedicated to Jerry Cade. Our hope is that the safety information provided here will help prevent this type of accident from happening again.
Jerry was a conscientious employee, a journeyman lineman with over 20 years of experience. But nothing we do now can bring Jerry back. What we can do, however, is remind ourselves that safety first is not just a catchy phrase we teach our children. Good safety practices reduce the risks we face every day in our jobs. There's an old saying, expect the best, but prepare for the worst. Maybe the crew was in a hurry to get that fifth pole procedure over with. Maybe not, but the crew surely never thought something like that would happen to them. Well, it did happen. And what we can do is honor Jerry by learning from this tragedy. For Jerry, we should never let this happen again.
When it comes to safety, it's important to plan your work, then work your plan. Attempting to shortcut a job may get the job done faster, but is it worth the risk to yourself or your crewmates? None of us can avoid risk in our line of work, but we can do our level best to prevent the chances of accidents occurring. An ounce of prevention is worth its measure when lives are at stake.
Okay. Guys got any questions about that before I pick it apart? Okay. It's a real life situation, guys, where somebody lost their lives because they didn't follow safety procedures in a couple of ways. Can anybody think of what they said Jerry did not have on when he cut this pole and it fell and broke the boom?
Harness.
Harness. He wasn't wearing a harness. It may or may not have saved his life, but he'd have had a better chance. It may not have slung him out the bucket, but you know, that could have been a factor in whether he lost his life or not. So just remember, every time you guys get in a bucket, you must have on that PPE. That harness is there just to save your life. So always swear what your company has for you there. Don't take any shortcuts. Don't say, oh, it's only going to be a minute for me to get up in this bucket and get it done and get down. So, but it just takes 1 second, guys, just 1 second for something to happen to change your life. So he did not have on his harness. That was the biggie there. And he made a cut. Evidently, he made a cut that was too big on the pole and got away from him, fell across. It must have been a pretty good sized piece of pole to break the boom and knock him out that bucket. So what we do at Duke is, and really the only time you're probably going to do pole chunking is, like I said before, you get up there and you guys are changing out a pole or adding a pole in line, and you're gonna set it. You're gonna set that new pole as close as you can to the old pole that's being replaced, unless engineer, specifies a different location. But you're gonna set that pole right beside the other one. You're gonna transfer the primary and whatever else is off on that pole to the new pole and get it tied in where it's going to be secured on the new pole. You want to make sure that your conductors are covered up on the new pole so you don't get into anything on that new pole. So, and just like he talked about in the video on chunking, is cutting it in small sections. And actually, there is a couple of different ways that you can do this. We talked about earlier, I think maybe in the earlier part of the week, we talked about bucket trucks and the jibs and being able to lift transformers and things. Well, what we like to do, if we were in a tight spot, we had 2 buckets in there. We would take one bucket, extend the jib out as far as we could on it, and then the other guy would be up close to the pole, and he would tie the jib rope around the pole, the piece of pole we were cutting. The guy next to the pole would take the chainsaw and cut that section of pole. And normally, 3 foot, 4 foot at the most. We didn't really want to take big sections out. If it got to a point where we, had to cut a good sized portion of pole out, at that point, we'd use the line truck boom, extend the fiberglass jib all the way out, extend it all the way out, run it out, hook it around the pole just like you would with the jib, secure that piece of pole and cut it. And most of the time when we did that, we were using tag lines as well. We'd take a hand line, let the block on the ground and tie a tag line to that piece of pole. That way somebody on the ground could be controlling it as they were bringing it out so it didn't get into anything. So those are the procedures that we like to use when we're pole chunking. And that is something that, and I'll give you the Duke Energy part of the plan, how we did it. First of all, of course, when we started the procedure of setting a pole in line, of course, guys, we had a tailgate meeting, or we called it a pre-job brief. We had a form to fill out, and we'd go over everything, how we were going to set the pole in to cover up. Did we have a hotline tag on our on the line itself? Did we need to de-energize it? All those things were talked about. And once we got the pole set in line and got the primary transferred over, at that point, we would stop and we'd actually have like a second part of that tailgate meeting where we would get together, the groundmen, the people who were in the buckets working, and talk about getting the old pole out at that point. So we just had to talk about our how to remove the pole. We wanted to make sure we had the right PP because we went from lineman mode, framing a new pole, moving conductors. Now we're going into a pole removal mode where we're cutting the pole out with chainsaws, and the PP had to change. We had to get earmuffs. We had to get maybe a face shield, a mesh face shield. If your company calls for it, you might have to wear chaps in the bucket. But most of the time, if you're in a bucket, you didn't have to have those things. But you wanted to make sure you had your earmuffs on, safety glasses. And then most of all, and we talk about this all the time, you had to have communication, the right communication. And everybody knew where you were at, what you were doing, communicate. You could have two-way or three-way communication from you to the man on the ground, from you to the man on the line truck or the other bucket. You just want to have that communication. That's important because you don't want to end up having something go wrong and end up like Jerry in the video. So that was important as well, that communication. Let me scroll through this one more time. And there it talks about the safety meeting. You saw the barriers that they put in place. They had the hoses on the line. Duke goes a little bit further because of certain accidents that were out in the field at times. They changed the procedures. And actually, sometimes it seems like they can go a little bit too far, but when you're talking about somebody's life, it may not be the situation. So follow all the safety rules. Hard hats. There's their cover-up guys. With Duke, it's a little bit different. We didn't use this kind of cover-up. We used the other rubber hoses and blankets we talked about, I believe, last week, kind of like what you see right. Let me get that guy right there. Those blankets, that's the kind of rubber that we use. Truck setup is important. And then there's your pole chunking. You can do it by hand line like that, or we like to use the jib. That way we weren't dropping it to the ground. There's only, of course, if there's only one bucket up there, you had to use this method, cutting it in sections like this. And guys, that's pretty much it for this video. Just, you know, when you're up there working, you just want to make sure. The biggest thing you want to make sure is kind of like we talk about a couple of times a week is not standing around under the pole when you're doing that thing, when you're taking material off the pole. If you see somebody walking under the pole, you need to holler at them, tell them to get out the way. Or if you're the man walking under the pole, you need to make sure you let them know, hey, I'm under the pole. Make sure they know you there, because it's, you know, it gets pretty loud with all the trucks and chainsaws and drills and all that going on. So everybody's safety is important whenever you get on the work site. Okay. Anybody got any comments they want to make about that, or got any questions about it? No questions. Okay. Let me stop my share. Okay. All right, guys. And I'll just say this too. I've had a little internet problem this morning. I may drop out just before you guys got on. My internet dropped out like 3 times with me and Professor Shoemaker on there. So if I drop out, hopefully it'll jump right back on within a couple minutes. So we'll just be aware with that. We're going to continue on with substations. I know we talked about the presentation a little bit yesterday. So I'm going to bring up another presentation from another gentleman that was in summer class last year. Let me share my screen again. And we're just going to kind of go through these components one more time. Has anybody completed the presentation yet? No? Okay. You guys started working on it?
The substation one?
Yeah.
Yes, we started one.
Okay, good. Can y'all see my screen?
Hey, V, did y'all put a Dropbox on that?
Yes, there should be one in a Dropbox. Let me check right here while I got you. You guys can see it.
I know yesterday I went to go start on it. I couldn't find a drop box. And I was just gonna wait until
Yeah,
you guys
I
started.
couldn't find,
All right,
I couldn't find one either. There was nothing in the Dropbox.
all right, we're in 112 assignments, Dropbox, substation presentation right there. It's in one.
Oh, all right.
It's not coming up like that on my end.
All right, I'll check the whether it's available. No, it's not visible right now, so I'll make.
Oh, okay.
Yeah, I'll change when we get off of here this morning. I'll change it and make it visible. I'm sure Professor Shoemaker will do the same thing. So
And you said that was due next Monday,
Tuesday,
Tuesday.
Tuesday?
Tuesday, yes, sir.
Okay.
Okay. Substation equipment. This is one of the guys you can call it substation equipment, substation presentation, and we'll talk a little bit more into detail about this right here, right now. And then I got another video to watch about entering into a substation here in a minute. Okay, so our first slide again is going to be transmission lines with very high voltages and low amperages can use smaller wire to carry electricity a long distances. The lines connect substations to switch yards. So if you want to use a similar explanation of that, that's fine. But of course, you can use the one you had on your first presentation you did. The high side switch, of course, it is a three-phase switch. It cannot make or break load. It's a visual opening point. It's a static whip to make initial contact. The static whip part, can you guys see my cursor on here moving?
Yeah.
All right.
Yes.
Static whip would be this piece right here. See the little ball? And it's to make initial contact on there because anything energized where you do not want to make or break load, it's going to draw an arc and it could flash over to the other phase. It could flash over the ground. Could be a pretty bad situation for you. So it's got the static whip on it to make initial contact. And remember what we talked about? I think it was maybe yesterday we talked about it. The what you have to have in a substation or really anywhere before you can work on de-energize or work on a piece of equipment.
Two visual
Two
open
open points?
Two visual opening points. You cannot, if you have one, if this comes off the transmission line and you have one switch open, and of course is going to de-energize the substation, can you work on the equipment? Can you work on that transformer or anything else?
No,
No.
no, because it's not two visual open points.
Correct. There could be a situation out in the field where the lights go off and the breakers aren't opened in the sub and you might get backfeed. However many volts it is, that puts a dangerous situation out there backfeed. So you do not want to have that situation. Okay. Automatic circuit interrupter. Automatic circuit interrupter contains SF6 gas to quickly extinguish the arc, used inside a substation to protect the transformer and trips on both incorrect voltage values and overcurrent values. And guys, somebody tell me on this switch where it opens up at. Anybody?
inside of the top bushing.
I'm sorry, I moved it.
Like,
all right, inside of which bushing? This bushing?
no, the one in the middle.
This?
Yeah.
That's correct, Trevon. It actually opens up inside that tube with that gas in there, that SF6 gas is in there to extinguish any arc that may take place in that tube. So, and actually, I know on the, I've had to open and close a couple of these switches that are similar to this. and there's an indicator on there that tells you if that gas in there, if the cylinder's full of gas or if it's leaked out, because you don't want to open that switch up if there is, you know, low gas in it, because that could cause an explosion inside that tube. So you want to be real careful with that. Make sure before it's operated that, you know, that tube's got the right amount of gas in it. If not, then you want to report that to your substation maintenance people, and they'll actually come in and do maintenance on that that switch itself. So that's an ACI, automatic circuit interrupter. You got any questions about the ACI, guys? And I'll tell you one thing I do like about what Santee Cooper does is all their substations are uniform. They're all the same, whether it's at Myrtle Beach, North Myrtle Beach, if it's in Georgetown, wherever their substations are at, they are all the same. And that's not really the same with Duke Energy, because Duke Energy was formed from many different smaller companies where, you know, one company started buying these other little smaller companies, and it just kind of grew and grew. And then there was several different kinds of substations. They all do the same things, but the construction on a Duke Energy sub is different from a Santee Cooper sub. It's not the same guy. So does the same thing, but looks totally different from what they've got built here. And I think that's a good thing, a smart thing, what they do with that. All right, guys, we're looking at a transformer. How can we tell that this is a transformer? Anybody?
The bushings are different.
This is a step down transformer. Which side is the high voltage side?
Right.
These larger bushings, smaller bushings on the output side.
The right side, bigger bushing.
That is correct. That's correct. That lets you know that this is a step down transformer. These fins that you see on the back side of this transformer, they are called cooling fins. There's actually, I think there's inside, you can see it here, maybe there's some fans inside of here to move the air around to keep the oil cool. Because in the summertime, with the amount of demand that'll be out in the field, with everybody using air conditioners, and mainly air conditioners to, you know, to cool your homes or businesses or whatever, that draws a lot of current, a lot of load, and it's important for that oil to circulate and keep this oil cool inside this transformer. I know I've been into many substation calls because of my job and where I was at located in the field, that they would call me first. It would normally take the guys from substation 2 or 3 hours to get to my substation. So I'd go check it out first whenever there was an alarm. Have to go check the temperature control, make sure the fans were working on the transformer itself and all, and make sure the transformer wasn't about to explode or pop a valve and shoot oil everywhere. So very important part of that transformer is the cooling fins on it, and those plates and the fans itself. Any questions about a step down transformer?
You can tell the difference between a step down and a step up.
How can you tell? That's a good question. I guess it works in reverse. That's a good question. We'll reserve that back for Professor Shoemaker when he gets back. But it's probably going to be the same. It'll just be in reverse, and it may say so on the nameplate. So I'll double check that with Professor Shoemaker, and he might can explain a little bit better.
Sounds good.
It shouldn't really be any difference with it, though, because you're going to have the same thing with the bushings. Okay. All right, guys. It's about 9:34 right now. Let's go ahead and take a break. And, be back at, let's give it 9:50. Come back at 9:50. I'm gonna give you a good break.
All right.
All right, gentlemen. It's 9:50. We'll continue back on with the substation equipment presentation here and talk a little bit more about it. We're on the step down transformer, and what it says in the description right here: step down transformer in a substation converts higher voltages from transmission.
You gotta share your screen.
Oh, thank you, appreciate it. Got it. You got it?
sir.
Okay, good deal.
Yep.
All right, now we're back with that. The transformer, step down transformer in a substation converts higher voltages from transmission lines to lower voltages for distribution lines. So it says it all right there. We talked about that. And guys, I'll just tell you that's the heart of the substation right there is that transformer. So that thing is looked after, cared for. It's very expensive. They can get up into millions of dollars for that. So it is very well protected from lightning or surges or anything else that may happen in a sub. So on the transformer itself, we talked about the fins over here for cooling, and that's for protection. Like I said too before, it has all kind of relays that are connected into this transformer that are monitored by dispatch. If they start getting alarms off this transformer, whether it's overcurrent or undercurrent relay, or they get whereas overheating, they'll get an alarm, call substation maintenance. They may call you to go do it. I know Professor Shoemaker, he said because he lives really close to one of the substations near his house, and he would have to go check on something in a substation as well. So just because your title says, a lineman, doesn't mean you'll just be, distribution. You can go check substation stuff as well too. So substation. So on this transformer here, you'll see as well, you'll see some current transformers, CTs and PTs up there. We talked about that too. And that's what they use to monitor the amps going through the transformer as well as volts to make sure it's in that, keeps it in that range that we like to have, that plus or minus 5%. So that's very important as well. And those ranges can be adjusted on the breakers themselves, and that also, we talked about engineering having to adjust tap changers on transformers or give you permission to do it, because they don't do it. The lineman will do it. They'll give you permission to take care of that. So that's a substation transformer. Any questions about the transformer, guys? Step up transformer or step down? And I will find out the difference whenever Shoemaker gets back. All right, now, next piece of equipment, guys, we got out there, that's the low side switch. It is a visual opening point. And how many opening points would we have to work on that transformer?
2.
That is correct. And that's the lower side voltage of the transformer. It is a load break, load make, so you can open this switch under load. And then I'm not sure, you can't see in that picture, there should be a crank, maybe a handle down here to crank to manually open it, or dispatch will open it up. So low side switch. Now, you can see right here on my screen, I'm toggling between low side switch and potential transformer. What do you think's missing? What slide should be in between the low side switch and the PT? It's the bus. the bus work right here. That should be, you can see it down in the bottom of this slide. You can see it here. And guys, can you give me a minute? I got a phone call I need to take. So I'm gonna mute myself out a minute. All right, gentlemen, I'm back. I'm sorry about that. I had to take that call. We're talking about the bus bars in the substation right there. That slide is actually left out of this presentation, but you need to make sure you have the bus in there right after the low side switch. And you can see in this picture, and you'll be able to look at it a whole lot better when we get out there and be able to get into this substation and look at this stuff. But you'll see this bus work runs from this far end of the substation, and it runs all the way back to the last breaker on the sub. And each one of these, you can see these, we'll call them bays, where they put the breakers. You've got one here, one here, one here, one here, and I believe there's one more on the end. I think Professor Shoemaker says Santee Cooper builds their substations for maybe 7 bays. Maybe 6 of them are used, and then they have a spare on the end, and which will be on this far end down here. There'll be a spare bay down here just in case they have to add a breaker or extend it, for another feeder outage coming out, feeder exit, sorry, not an outage. But but that bus work runs the whole length of all this, where all these breakers are set in here. It leaves the low side switch and then ties in. You can see where it ties into right in this area to the bus work. So how many types of bus bars are there in this? What kinds are there? How many? Anybody? Remember we talked about that earlier. There are actually 3 types of bus bar in a sub. Flat, tubular, strain. You might want to add that in when you put your bus slide in there, that there's those 3 types. Okay. Any question about the bus bars? tubular, strain, and flat. Can you guys hear me okay?
Yep.
Okay, cool. All right.
Yes, sir.
We talked about PTs and CTs a little bit. These are potential transformers. They're very low kVA, maybe. I think Professor Shoemaker said they were like maybe 1.5 kVA just used, and they are just used for measurements of high voltage in substations. And that's really, guys, I mean, I never thought about that a whole lot until I started going into substations more of how they monitored voltage, you know, the breakers and all. I didn't ever see any high numbers like Duke Energy. Our primary voltage was 13,200 phase to ground, 23 kV phase to phase, pretty high. And I always look for that number on there, but there's no way, you know, that they run 13,200 volts down inside of that cabinet to monitor that voltage. So they would use those potential transformers to step that down to a readable level. So it's more or less like you're reading 120 volts or 240 volts phase to phase, just like on a secondary voltage. So that's how they transform that down to where you could tell, you know, it was like 120 volt was in relation to 13,200 and 240 volts was in relation to the 23 kV. So very good piece of equipment. And then of course the engineers would be able to monitor to make sure everything as well. And the way technology is today, they don't have to actually go into substations anymore unless there's a communication problem. They can monitor this from their desk, each breaker, to see what they're doing, you know, how many amps they're, you know, that each phase is pulling, those kinds of things. So it's a good piece of equipment in the substation. Bus side disconnect. And why is that? Which side of the breaker is the bus side? Is it the incoming or is it the outgoing? It's on the
Incoming.
Ingoing.
Say it again.
Incoming.
Incoming, that is correct. It's located on the bus side of the breaker, cannot break or make load, and it is a visual opening point. And you'll notice in this picture, he's got the bus side of this circled here. So it comes off the bus bars, this flat bars, goes to the top side of this switch. We call these solid blades, a solid blade disconnect. You cannot open it under load. You cannot close it in under load. So it's used as a visual opening point. So it goes from the bus bar down to the switch, through the switch, and to the switch itself, the breaker. But you can see that these are mounted back to back. The bus side disconnect and the line side disconnects right on the other side over here. We'll get to that one in a minute. So guys, any questions about bus side disconnect? And anytime, guys, I'll tell you this too, I've kind of left it out. Anytime that you're in a substation, you're asked to go in a substation, you might have to work on that breaker or the regulator, something in there, and you have to kill the power to this to be able to work on it, de-energize it. You have to flag and tag each one of these disconnects. There's 3 of them on this side, 1, 2, 3. There's 3 on the back side, 1, 2, 3, and you have to actually put tags on them to let somebody know, hey, this switch is out of service. And it serves to let you know as a reminder as well, hey, I can work on this equipment safely. I've got 2 visual opening points. Of course, we talked about PTs, now CTs used to measure current and voltage located on the top of the breaker. So there's CTs inside of this to measure current going out in the line. Anybody got any questions about the CTs? No? Okay. The breaker itself, this box, there's many different kinds of breakers. How do we know this is a breaker and not a transformer?
Bushings are all the same.
Bushings are all the same on this piece of equipment. It opens due to overload or fault on any one of the any one phase or more, opening all three phases. So if there's a fault out on the feeder somewhere and a tree limb falls across just one phase out there, is one phase of that breaker going to open, or are all three going to open?
I'd say all three.
All three, that's right. You just don't want one phase to be out because you're going to have an imbalance out in the field. Customers or three-phase customers may at that point start single phase, and then that's bad for them. So it's designed, if you get a fault on one phase, two phase, you know, then all three phases are going to open up. And so you can see where it leaves the bottom of the bus side disconnect and it goes into the top, the bus side of this breaker. Typically using substations can be moved to other places. Oh, not really. This is about the only place you can use one of these breakers inside of a sub. This kind will be used inside of a breaker. Any questions about the breaker? It actually does have settings inside of it where, and we actually go into power systems. We'll talk about breaker operations more, but it operates to try to clear a fault before it actually locks itself out. It really depends on the engineer who set up these breakers in the sub to how many times they operate. But if a limb, I know in the Duke system, if a limb falls across these phases out in the field and that breaker operates, it has what it calls a quick trip. That means or instantaneous trip. It'll trip very fast. It's like less than a second. It trips and comes right back on. If the fault's on it again, still on it, it'll actually trip again and stay out for like 10 seconds, come back on. If the fault's still there, it'll operate again, it'll trip out again. And I think that's another 15 seconds or 20 seconds, depending on who sets up the breaker and the times that it operates. And that fault is on it a last time when it comes back on, then the breaker will, it'll actually open, it'll operate and open and clear itself right there until the fault is cleared. At that point, you'll have to go out, patrol the line, find the fault, clear it, and then dispatch can re-energize that breaker. But that is a substation breaker. And with automation, the way these things work with SCADA, that does make it easier on you as a lineman. Because when I first took the job in Andrews down here, I had one substation. And if I had a fault out in the field and it locked that breaker out, I'd have to come to the substation and go in there and visually see that all three phases were open. It would show me lockout on there. Then I would have to start patrolling the line, look for that fault, find it, and then go back to the substation, put it on hotline tag, and then I would test that breaker again. If that was not the fault and it locked it back out, I'd have to do it all over again. I'd have to go back in the field and I'd start patrolling. And sometimes it may take 30 minutes. It may take an hour. It may take 2 hours, depending on the fault and where it's at and how big it was, but it takes some time. But with technology today, they can actually give you a certain area of where that fault is because of the high current that flows back to the breaker itself. It can tell you how far down the line that fault is. And you can go look. And Duke was good about it because they would give us like a 3-span range. They would give us pole numbers to look for. And usually they were pretty close to having the location of that fault. So made it easy on us that way. And as well, when we cleared the fault, we could tell them, look, I got men, tools, equipment, and clear. Close that breaker in. And that's what they would do from dispatch. They would close that breaker in from remotely from Raleigh. So I didn't have to go back to the sub. I really never had to go into sub much anymore at that point. when they automated the substation. So good technology out there. And I know Santee Cooper utilizes all its technology as well. Any questions about the breaker?
Usually what causes a fault like that?
Several things. It could be a car hitting a pole. You know, and I got a video I want to show you on that. It shows a car hitting a pole and the breaker operating. Let me see if I can find it right now. It might be a tree line, you know, a tree falling across it. Something small as a squirrel getting on top of a transformer can cause it, or another piece of equipment out there. A lot of different things. Lightning strikes, broken insulators. Let me see what this is. No, that ain't it. I don't have it. I canceled it out. But anyway, good piece of equipment, like I said, but lots of faults can take them out. You can put it on hotline tag when you're working out in the field, like you're changing out a pole or you're moving some phases of ground, and you don't want it to operate those 3 times. You just want it to go through that quick operation, that first one. And then you want it to go right out if something happens. And that's what we call a hotline tag. I think we might have talked about that before, but you don't want to touch primary unless you do have that hotline tag out. So if something happens, it'll take itself out. So good piece of safety equipment. Any other questions about a breaker? Okay. And you want to make sure you got all your PPE on when you're going into this, because you've got stuff you have to check on inside these doors and possibly take this panel out, and you can see how close to the ground you're standing. I mean, you're just within a couple feet of these hot primaries coming off that bus bar. So make sure you have all your PPE on before you go into this sub. Voltage regulators is your next piece of equipment. And you can, I don't know if you can see where it goes off the transformer and then over to the regulator, but we talked about regulators before, guys. What's another name for a regulator? Anybody remember that? Anybody? Power systems, we'll talk about a little bit more, but it's called an auto transformer because it raises and lowers voltages. It's got 8 raised positions and maybe 8 lower positions on that regulator where it steps up the voltage. Our new substations that we were building were this construction where the regulators were behind the or in front of the, or behind the breaker going out onto the field into the feeder. Duke, like I said, their substations were different. The older ones, my substation had 1 regulator, and it was behind the bus work between the low side switch and the bus was my voltage regulator. And it was what we call a regulated bus. It regulated the bus work for all the breakers in that sub. Had a few instances where snakes would get into a substation, climb up on the breaker, and take the whole sub out. Any fault that I had in there from that bus side back to the transformer, it would open up the high side switch and take that sub out. So I think this is a pretty good way to build them with the voltage regulators beyond the breaker. So 3 voltage regulators, and that's a way. Professor Shoemaker says that Santee Cooper does some of their phasing out in the field to tell which phase it is to raise and lower a voltage regulator. And you could put a primary voltage indicator out there, and it would tell you which phase, because you could actually see the voltage raising and lowering out in the field. And it says in the description, voltage regulator helps maintain constant voltage on a feeder line by raising or lowering the voltage to adjust for load. They are especially used on longer distribution lines. And being that he put that in their longer distribution lines, you will see these out in the field. There may be 1 on each pole. There'll be 3 of them, or they may be on a bank. It's a platform, all 3 of them. So you've got either them in the substation. If it's a very long feeder, you'll have voltage regulators out in the field regulating voltage on long feeders. So voltage regulator, good piece of equipment. Last, well, next to the last is your line side disconnect. Same thing as the bus side disconnect. Does not make a break load, visual opening point, and located on the distribution side of the breaker, which is actually beyond the regulator. So if you had to work on the regulator or the breaker right there, then you'd have to open up both the line side and the bus side disconnects, flag and tag. And if you did not, and somebody came by, saw you working in the sub without them, that's a pretty serious offense as far as Duke Energy goes. And you'd probably get written up and maybe have a few days off. The last slide you want to have on here, I don't have a picture of it, would be the distribution feeder. You can see where it comes up here, and these lines are going out into the field. Any questions about this stuff in the sub? Any of that equipment, the order this in? Okay.
Mr. V, I got a question. Is the line side disconnect before the breaker or after?
The line side disconnect is after the voltage regulator. You go bus side disconnect, then you want to go down to your feeder breaker, then to the voltage regulator, and then to the line side. Bus side first, and then your line side. That makes sense?
Yes, sir.
Okay. Any other questions? Okay. I hope that helped you out with your project coming up with this. I'm gonna stop share with this right now. I think we had somebody out here trying to get in. No? Okay. All right. Let me show you this. I'm gonna share my screen one more time, guys. I want to show you this substation video. You guys see that?
Yes, sir.
Yes.
Okay. This is a short little video.
Today, we're about to enter one of our switch areas. We're going to be going over 3 things you must do no matter where you work. All right, so first step, guys, before we even go inside, is we got to notify our dispatcher. Some companies may not have a dispatcher that they notify as part of their procedure, but you're out here in the middle of nowhere by yourself, somebody's got to know.
And that's a good point. And I think I talked about it before. Before you enter a substation, you have to notify dispatch that you're going in there just in case something happens in there. If you might fall out in there, something, get sick, can't make it out because they got it notated that you're in the sub. And if they haven't heard from you, say within 15, 20 minutes, they're probably going to be calling you on your cell phone, wanting to know, hey, you okay? Just to keep up with you. So it's very important to let dispatch know that you're going in the sub. I know with Duke on the very rural substations that they've got out there, they actually went installing video cameras in there. And that was one for your safety. That was for the public safety. And 2, people think there's all kind of copper inside of these substations. And they were breaking into them, and that's just a monitor substation to have a little alarm go off like a motion alarm. And Professor Shoemaker has one with his video camera at his house, but it would actually go off and be able to show them if somebody was, moving around inside that substation or whatever. But want to make sure that dispatch is notified before entering a sub.
A lot of this equipment in here is remotely operated. You don't want to be underneath an air breaker as it's being remotely operated. Those things are loud, they could fail, there could be compromised equipment in there. It's just a good idea for someone to know where you are. Pretty standard procedure, only takes a minute. Give your dispatcher a call and let them know which substation you're at or switch yard and what you're doing there. Just going inside to update my computer. All right, thanks. Easy enough. All right, let's go open up that gate. All right, so we're inside. Our dispatcher knows we're here. So what we're going to do next is our perimeter check.
What kind of truck's he driving? What do you think? Do you think he's driving a pickup truck?
It looks just like a digger truck.
Well, it could be a digger. It's a bucket truck's what he's driving. And what did he just say he was going to do? Drive the perimeter of the fence in that switch yard? That's not a substation, a switch yard. That's one thing that you probably will never do with Duke. You'll never, I'd say 99% of the time, you would never drive that truck inside of one of our substations. I noticed Santee Cooper's got a lot of room in the front side of theirs, so it may be okay to go in there. But you don't want to drive a big bucket truck or a line truck like inside that substation if you don't have to, because of the height of the boom. You don't want to drive through any distribution line. You don't want to drive through any high voltage line with that truck, because that's going to be a bad day for somebody. So what
we had to have 2 employees. If you drove a big truck, bucket truck or line truck into a substation, you had to have 2 employees. You're not driving there alone.
That's right. You didn't want to go in there without a spotter. So this guy's, their rules are a little bit different for their stuff where he's at. He's up north somewhere.
So you would have to let dispatch know that you and a buddy was inside the substation.
Exactly. You just didn't want to go walk into a substation. You have to notify dispatch and let them know that you're inside that substation. So, and like I said, that's, go ahead.
So I see where your head is at, Torella. Say you've got a substation maintenance crew that's in the station, and you've got a relay crew that's in the station, and a communications crew that's in the station. All of those entities, including yourself, have to say that you're there.
Right.
Okay.
Yeah.
They want it all documented, no matter if you're working it together or separate. Who's all in there?
That is correct.
Yeah, the engineer might want you to go in there and get a counter reading off a breaker, but you still, I mean, that's like a 2-minute job. So, but you still got to let them know you're going in. And one thing this guy did as well, when he went in this substation, it didn't show it, but he didn't lock the gate behind him. That's a requirement with us. You had to lock that gate behind you. I can't tell you how many times I've been in the substation on an outage. Folks that had the lights out knew where our substation was at. They'd come rolling up to the substation and just come barreling in, walking right in the sub on me, and I'd have to escort them back to the gate, because that's no place for the public to be. That's, that can be a dangerous place for them to, to come into.
Yeah, no.
That's
we had
right.
we had some safety concerns about that before, because we're thinking, well, if we go into a substation and an accident does happen, either singularly or a couple people, well, how are the emergency crews supposed to get to you if the substation is locked?
Right.
Emergency crews are not allowed in substations.
Right.
You have to have somebody let them in. So really, you got to lock the gate behind you.
Yeah. We I didn't lock myself in. I kind of dummy locked it, just kind of put the lock back through the chain or whatever and kind of let it hang there. Because usually the breakers, they weren't really far from the gate itself. So that was one of our rules.
Get a look real close, because sometimes it gets pretty crafty. They cut a couple of the buckles at the bottom, squeeze under the fence. You can hardly even tell anyone was here. So you want to drive around the entire perimeter, making sure that nobody broke in over the weekend. So we just stopped for a quick second. I'm going to show you guys the spot in the fence that was cut last year. See right here, it's been repaired now. Somebody cut a hole in the fence there and crawled underneath to our substation. Not sure if you guys can hear that right now, but man, that high line is noisy. Snowy day, she's making a lot of noise up there. That's 230,000 volts over our head. Going into that massive power transformer over there. All right, let's continue our perimeter check. All right, and we are going to stop here for minutes. So you can see in front of me here, the lines in the gravel where their vehicles have been doing their perimeter check. And they're driving right underneath this high tension line here. It's 345,000 volts. That's fine. Those tracks are from our vehicles from the substation techs, engineers. Anyways, guys not driving boom trucks. When driving a truck in through a substation, when you're passing underneath equipment, the height of your vehicle cannot exceed the height of the grounded stand that the equipment is sitting on. Those massive PTs, they're on a steel stand. It's about 7 feet tall. Well, my truck is 11, almost 12 feet tall. So as long as the vehicle you're in doesn't exceed the height of the grounded steel equipment, you're good. While you're doing your perimeter check and inspection of the terminal, a lot of these places have something that looks like this. It's kind of like a sidewalk going through the area. They kind of zigzag through the terminal. Those are actually cable trays. Here, there are some cables underneath. Those are bolted down. You don't want to be driving over top of those. Last thing you want is for your 30,000-pound service truck bust through those boards and damage some equipment, your truck, somebody get hurt. So most of them have something that looks like this. We have a concrete crossing area. Now I realize not all substations have that type of setup. However, it's something to look out for if you have cable trays. Don't be driving over top of them. Which brings me to the third and final step of what you should do whenever entering a substation or a switchyard. And that's just a general inspection of the equipment. What makes our system the most dangerous is when it's compromised. Everything in this subyard is bonded together. Every bit of like the steel building, the ground grid, all the towers, any equipment, switch handles, everything is bonded together to be at equal potential. Just a very general inspection of the area, making sure that everything's safe. All right, guys, so we're in the building now. We just completed our final check, which included checking for any alarms, basically, on the system. There's all kinds of panels in here, which include targets and alarms that monitor virtually all the equipment in the subyard. Most of it is connected to our dispatcher, so if there was an alarm, you probably already know about it. Don't want to get too much in this, and neither should you. This is more for a relay tech or a sub-tech's job, but you should have a general knowledge of what you're looking at when you're in these substations. So that concludes this video, guys. We're going to go over it again real quick. 3 steps, no matter where you work, to perform whenever going into a substation. First step, let your dispatcher know you're here. Second step, do a perimeter check. And third step, a general equipment check. So thanks for watching, guys. Make sure you subscribe.
All right, guys. I mean, I agree with that. Do your checks. The first thing I like to do when I went into our subs is, make sure the lock wasn't cut. Because like I said, they think that substation is full of copper. There's some in there, but not like what people think. They think they're going to get rich by going in and stealing copper out of a sub, which is not the case. But you want to make sure that, and what a practice was of ours, we had to wear our rubber gloves, especially if it was during a lightning storm we were going into sub. We had to wear rubber gloves into that substation, to unlock the lock on the gate going into substations. You just didn't want to go in there. I know I've heard tales of this from the older linemen. When I started, they said they, going to a substation before the SCADA days, and they had to go in there manually operate the breaker, and it'd be lightning all around them, and they'd see blue fire going around the perimeter of the substations. I never saw that, and that's why they say you wear your rubber gloves. Professor Shoemaker, have you ever witnessed that?
Not on lightning. I have not, but when you're in a substation, do not lean up against the fence. Don't lean against any steel structures, put your arm on it, or anything like that. I did have the occurrence of being at a substation, and the supervisor closed the breaker, and there was a fault on that circuit. Well, the fault was a phase to ground, and of course, it's going to follow the entire system. And I was leaning up against the fence. And I tell you one thing, it buzzed me pretty good because that fault current was trying to go to ground. So that it's not related to lightning; it was related to a line fault. But firsthand, yeah, it will happen. If they're closing breakers or there are faults happening on your system and you're in a substation, isolate yourself from everything that's ground and just stand on the rock.
Right. Yep, that's because just remember, like we talked about potential before, that includes a fence at a substation. You know, you're standing outside and you don't want to lean up on that fence because that's two different types of potential. You could be the path to ground for something. So you want to be careful with that. All right, gentlemen, it is 10:31. Let's take about 10 minutes, come back about, let's call it 10:42. Take a break. You guys hear me okay?
Yes, sir.
Just wanted to check. I just don't trust my internet today. Before we proceed on, is there any questions about anything to do with the substation? Like I said, we'll go into substations into more detail a little bit later on. We just kind of wanted to hit you guys over the head with it pretty good with the presentation due next week. And hopefully maybe next week, if everything goes right, maybe we can get a chance to go into the substation itself and see things firsthand. First, Shoemaker, you got anything you want to add?
Can you hear me?
I can hear you.
Okay. Just on the part that you were discussing, I know I've been away, you probably already discussed this. When you go in a substation, daytime and especially nighttime, because I've seen this occurrence, for some reason, kids and adults like to throw things in substations.
Yes, they do.
And on a couple of occasions, I've seen bicycle chains and clothes hangers hanging down from the conductors.
Yeah.
Take your time and look up. I don't know why they do it. Sometimes, you're going to get an explosion out of it, but you're going to have some other variables in there. And those, I actually saw a guy walk into a substation at nighttime and walk into a clothes hanger that was hanging off of 7200 and it bumped on his hard hat. Well, luckily he had his hard hat on. So it's very important that when you go into a substation, take your time, one, and look up.
Yeah.
Look up, take your time when you're walking through a substation and inspect it carefully.
Right. Absolutely. All right. If there's no more questions about substations or any comments that you guys, I'll give you a second to think about it. There is going to be a quiz today. Guys, we're going to have a small quiz out there on what we talked about yesterday with the 3-phase overhead transformers, tap changes and those kinds of things. So look for a little quiz out there. Probably be after 11. So we'll let you guys know whenever it's out there. So it'll be a simple quiz for you. Shoemaker, you got anything else? Uh-oh. Did we lose you? He's froze up. Guys, and I'll just throw out some stuff here about the quiz. Like there's going to be some questions, maybe like how many cores are in a 3-phase self-contained transformer? which bushing serves as both the primary and secondary bushings. What must you do first before changing positions on a tap changer on a transformer? Who must authorize you to change the change settings on a transformer? How many primary bushings are on a 3-phase self-contained transformer? Those kinds of questions. We've got to come up with a few more, but it's going to be those kinds of things that we're looking for on the quiz today. You can actually go back to the video from yesterday and look at it, and you should be able to get all the answers from there. So it's going to be pretty simple what we're looking for. So, Professor Shoemaker?
Yes. Have you discussed why we're online today?
I did not. I was waiting on you to come back.
Okay, gentlemen. So just for your information, we did have got notification yesterday that we did have a student that tested positive for COVID. I'm not able to give names here. And that student also had some interaction with some other students. So obviously we're going to have some quarantine time for some students, and that's why we went online. I took it one step further because it was a Thursday. We went online, so this gives us Thursday, Friday, Saturday, Sunday, and obviously we'll be back online Monday, and hopefully the ones that are not quarantined will be back out in the field Tuesday. So there's a couple points here. If you're sick and you don't even know what it is, don't come to class. Don't come to the field. Online's okay if you're feeling well enough to come online. Just text me, let me know. I don't care what it is. You know, I got a headache, I got an upset stomach, anything that's going on, those are precursors to COVID-19. Just let me know. That's one point of it. If you do have exposure and you know you've had exposure to it, you need to let us know. Even if you haven't contracted or tested for anything, please give us that information. Text me and let me know. Of course, we're going to keep that information private as we can. I would suspect that you guys are texting each other, so that's completely up to y'all. And the last part of it is, don't think that if you miss a day of class because of sick or COVID or any of those situations, luckily you have two professors here and we teach the same exact thing. We've had cases before, and we can accommodate your absence because of, for whatever reason, you know, as far as your health is concerned. So be proactive and be responsible when you think that you might be running into a COVID situation or, you know, really any kind of contagious sickness that you may have, and let us know what's going on. So, you know, I took it one step. We could have gone to the field today, but I felt it is, you know, we're going to throw it out, you know, one day more, and we're going to actually, to be honest with you, we're quarantining ourselves for the next 4 days from each other.
Yeah.
If you really want to consider it that way. So if you have any concerns and you want to stay behind about, well, I don't feel comfortable coming to class Tuesday or whatnot, you know, it's a little bit early to tell that, you know, stay behind and talk with us about it. But that's pretty much it. Of the cases that we've had in history, how many have we had? Professor B, 3?
Yeah, 2 or 3, yeah.
Yeah, 3 in historical classes. All of those students were able to get their ELW certificates. We got them through. Of course, you know, Professor V are very accommodating for situations like that. And like I said, he can take over the full online class, and I can take the other person or persons if they missed a portion of the outside part, and I can take them to the field, or vice versa. We cover each other. Are there any questions there? Or like I said, if you want to speak privately after this meeting, you can do so also. Okay, Professor V, that's all I have.
Okay, well, that's, guys, unless if you guys don't have any more questions, give us a little bit to get this quiz together and get it online, and we're going to make sure that's it. Make sure the Dropbox for your presentation is going to be available. I've got to change some settings on mine to make it available so y'all can see it. Just take your time with it. Just if you have to go back through today's recorded, yesterday's recorded, just go back, look at those things, and if you have any questions, we'll be here for a while. So,
Okay, just to give you a heads up of the meeting that I had this morning, that was referring to CDL. So I know myself and Professor V have been constantly saying, you know, get your CDL permit. Continuing education has become really proactive. It's a subdivision of the college to offer a 5-week CDLA license through the college, fully scholarship. And that includes your drug testing, your physical, and your CDL permit. So the continuing ed group will be meeting with us 3 p.m. and we'll send a reminder out to you 3 p.m. on March the 16th to talk to you guys about it. Hopefully I have some information to send you as far as what the program is all about. They said they would send me some information to pass on to you guys. But if you want to add that CDL permit A to your resume and have it fully paid for prior to employment, this is a great opportunity to get that done.
Yeah.
Okay, Professor B, that's all I have.
Last thing I want to ask is TT, have you nailed a date for next week when Mark Jones is coming?
He hasn't talked to me since he sent out that email.
Okay.
About everyone paying. I guess he's waiting for a certain amount of people to pay before he announces what day he's going to come.
Okay.
Well, he's pretty much going to look for all people to either give a credit card or confirm that they will pay on site. And I will, we probably need to say this again because it's way back in orientation. No checks.
Right.
No checks allowed. It's either got to be hard cash or a credit or debit card prior, or you can use a credit or debit card at the site. I mean, if you do it now, obviously it saves a ton of time. You can do it on site when he gets there. This is what happens to some of our younger students, 18, 19, 20 years old. You got a limit on your card. So if you know you got a limit on your card or you don't know, and you need to find out, go ahead and get prepared for that the day before and say, well, I'm getting ready to buy some tools for college. I need my limit raised to whatever the cost of your tools is. So I've had plenty of students come in that's, you know, wanted to pay on site that day. He will run the credit card by phone and then it'll come right back over the limit. Then you got to call the bank. Then you got to wait so many hours. Then you got to, you know, get approvals. It's just kind of be prepared for that situation.
Okay. Guys, you got any questions, concerned about your tools?
I will let you know, Mr. Granger, we were out there speaking with transmission. I think it was Justin up there. The handline block broke on you and fell down. He was not happy at all about that situation as far as our hard hats were concerned. So guys, stay away from the bottom of the pole. We do have, what, 4 hard hats?
Mm-hmm.
If you need to get up under a pole, and we've got the sanitizing wipes in our trucks, if you need to get up under a pole, it's just like the fuse barrel that we're changing out, get a hard hat on.
Okay.
Okay.
I got one more question for you, Professor Shoemaker.
Yes, sir.
I think Trevon asked it. It was concerning a step-up transformer. Can you tell the difference between a step-up or a step-down transformer? How do you know which one's which?
In the purpose of what you're going to be using it for, it will be labeled step up.
Right.
So the tag, and especially when you're at a generating station. When you're at a generating station, it's going to have either on the fence that surrounds it or on the tag on the transformer, designed to be a step-up transformer. That's its purpose. Hold on one second. I'm going to get a picture up here.
Okay.
Generating station. Images. Let's see if I can find one.
might be able to zoom into this one. You guys get the, yes, pretty big picture. All right, I'm going to share a screen here.
Got it?
Okay. You'll notice, well, it's easy to determine right here. How many generators are in the substation? I mean, in this generating station?
Oh,
4. How did you determine that?
What's on the wall?
By what's on the wall?
Yeah.
100% correct. Okay. A step-up transformer, and this is where you're going to be using that and what the transformer is designed for, has to accommodate. Now think of this out there in the real world. Generating typically will not go over 34,500 volts on the generator coming out to the step-up transformer. The reason why they do that is 34,500 or lower is much easier to insulate. So if we need to get that from one point in the generating station out to the step-up transformer, obviously that's a lot easier to insulate. Your clearance distances could be lesser. You know, we don't have to have big structures to get that outside to the step-up transformer, right? But if I'm generating at 34.5 and then I'm outputting on a transmission line, let's say at 230, the rule still applies. If I raise my voltage, I do what?
Lower your amp.
Lower your amperage. Vice versa. If I lower my voltage, I
Higher.
the amps.
Raise the amps.
So the amperage output from a generating station to the step-up transformer is huge. When I say huge, you're talking in the 4,000, 5,000, 6,000 amps per phase. What kind of conductor am I going to need to get it from the generator to the transformer? Something small or something relatively huge? It's got a lot of amps on it. Huh?
Big. Huge. It has to be big if it's got a lot of amps.
It's going to have to be huge. So I'm going to have a transformer that's able to accommodate that much, much larger conductor in the bushing of the transformer. Some of these actually go straight into the transformer. I don't use a bushing at all and connect to the windings. You will see in normally, you're looking at a conductor, and I don't know if you can see my hands. It's either this size, sometimes even bigger, of solid copper. And that's able to carry a lot of amps on it, all right, to get it into the step-up transformer out there. I've got to have a transformer especially designed to be able to accommodate that big old huge copper conductor. And then even with that, most of your generating stations here are going to put that in a nitrogen atmosphere. Well, what does anybody know what liquid nitrogen is? What's its properties?
Freeze.
There you go. It keeps it extremely cold. Okay, and when I keep something extremely cold, it conducts better, and there is some insulative properties to liquid nitrogen. So to answer your question, I know it took a little bit long on that part of it. Yes, there are step-up transformers are especially designed for the application they're put there for, but every transformer can step up. That makes sense. I'm not going to take a pole mount transformer and hang it on a pole and feed 240 volts in it to feed a primary line. Just does not make common sense. Okay, and it's not designed for that. Will it do it? Yes, it will do it, but it's not designed for that. Whereas a generating station step-up transformer is designed and constructed to step up voltages. Does that answer the question? I hope it does. Sounds good to me.
Yes, sir.
Okay.
Yes, sir.
I'm going to stop that share then.
okay.
Okay.
All right. That's the last thing I know of today. Guys, y'all got any questions or comments about anything? No. Mr. Shelley. Hang around for a couple minutes when everybody leaves, okay?
Yes, sir.
Okay, thank you. If there's nothing else, guys, we'll get a quiz together shortly and have it out there for you.
I got a quick question, Professor V. So with the substation presentation, there's 12 slides. Is that correct?
Let me
If you want.
Let me count them up. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 slides.
13. Okay. I just didn't number them. I just wrote them down. I just wanted to make sure I was
Yeah.
getting what you were getting.
Yeah.
So there's 13.
That's what I counted just now, 13.
Okay. Yeah, I got it now. Okay.
Yeah.
I was just making notes to the side. I see.
Yeah.
You
All
know,
right, thank you,
Scott,
sir.
Scott, you bring something up there. Do y'all remember the grounding test?
Yes.
All right. How many steps were there?
There was 24 back and forth.
Right.
12 apiece.
24 back and forth. What do you mean back and forth?
Like re-energize, de-energize.
So there was 24 steps, correct?
Yes.
All right. Some of them, and you know, this is okay with us. Some of them took my notes literally on the video. There were 24 steps, but let's say in the part where you had to attach the ground to the ground rod and uncoil it, I made that's 2 steps in one sentence.
Right.
So that was really 22, but I read it.
Mm-hmm.
Right.
So those students still got fine. If you put a slide up there that's got the step up transformer and you want to add CTs to it, perfectly legal.
Oh, okay.
Okay, so there's
So like if I at the beginning, I could add in like the air brake switch after the transmission lines.
if you got a picture of both of
IPR.
them in the same clip, yeah. Just make sure you
Okay.
explain both.
Okay.
Okay, that's legal.
That answers all my questions. Thanks, guys. Appreciate it.
Professor
You guys
Shoemaker.
have a good one.
Yeah, let's see. What's up, Trayvon?
Quick about that CDL class. Is that during the course or after?
For right now, because this semester and implementation will be after. Now they're trying to make it as close as possible from the May 8th graduation date. I do not have that information as yet, but they will. I told them I wanted a quick turnaround. As soon as you walked out of my class, they were able to walk into that one. So now next semester, they're going to do both. They're going to try to get, and it's 5 weeks. They're going to go into our students